So we're going to do chapter 4.2, which is building linear models from data. And I'm going to just show you a couple of things here. One is to draw and interpret scatter plots. Now, linear models can be constructed by fitting a linear function to the data that can be represented as ordered pairs. The first step is to plot the ordered pairs using rectangular coordinate. The resulting graph is called a scatter plot. Distinguishing between linear and nonlinear relations. Scatter plots are used to help us to see the type of relation that exists. Here we have an example of a linear model or two linear models. One has a positive slope, one has a negative slope. And the rest of these are examples of nonlinear data. So I want to show you how to do a scatter plot with your calculator. So if you have your calculator, open it up and follow my steps as I do them, okay? So we've got the following data represents the weight in grams of various candy bars and the corresponding number of calories from each candy bar, and it has candy bars listed from A to J. We're going to use weight as the X list and calories as the Y list. So let's go to our calculator, and I want to show you exactly how to do this, okay? So open Y equal, I'm going to clear this out the way, okay? Let's go ahead and clear everything. So you would have a clear screen, then press the Stat button, S-T-A-T, and select number 1, which is edit the list. Now, if you have data in any of these lists and you want to clear the data out, the first thing you want to do is to go up to that top of that list so that the top of the list is highlighted. Press the clear button and press enter, and it would automatically clear everything in that list. So we're going to put in all of the data for the X column here, which is the weight of the candy bars. 50.3, enter. 50.45, enter. 46, enter. 52.4, enter. 56.7, enter. 48.3, enter. 62.7, enter. 58.3, enter. 64, enter. And 61.7, enter. Next, we're going to put in the data for the Y column, which is the calories from each candy bar for each corresponding candy bar. So the first one is 384.9, enter. 401.5, enter. 368, enter. 379.2, enter. 409.1, enter. 378.9, enter. 407.1, enter. 392.9, enter. 422, enter, and 404.1. Then take a few minutes and make sure that you can, oh, I forgot to press enter here. Recheck your data, make sure everything is okay. Now the next step you want to do here is go to y equal and clear anything that you have in there. Okay, clear anything you have in there. Now I'm going to press the zoom button and scroll down to zoom. Before you do anything here, we want to have a proper graph. So press second and y equal, which accesses the stat plot button. Again, that's second and y equal. And you can see plot 1 is off. So I want to edit plot 1 and put it to on. So I'm going to hit enter. It's going to say list 1, list 2 in here. And if you don't have the type of plot highlighted, make sure that you highlight the scatter plot one. Okay, now press the zoom button and you want to select number 9, zoom stat. And this is the calculator's plot of the data that you just input. Okay. Now, I want to do a couple of other things here. I'm going to copy and paste this and put it into our scatter plot or data. So next thing I want to do is get an actual equation for this data. So I'm going back to my calculator. Here you want to press the stat button, scroll over to calculate, and you want to select number 4, linear regression line AX plus B. And what this does is it's going to create the equation for you based on the data we have. So it's saying that the A value, the slope is 2.4, and the B value is 260. Okay, so I'm going to put that in here because we want to make a comparison later on. Copy and paste it into our notes. Now, if I were to ask the calculator to plot this line here, let's say 2.42 to 260, let's see what would happen. If I went to y equal and put in 2 as the slope, or better yet 2.42 as the slope, times x plus 260, which is what I got as the the slope and the b value of 260, right? If I went there and put in that data and went back to my graph, it would give me what's called a line of best fit. Okay, a line of best fit. And this is based on the calculator's perception of this data. Okay, now I'm going to paste this in here. So what we have here is the scatter plot first. Then we have the linear regression line, y is equal to ax plus b, where a is given from this, so y is equal to 2.42x plus 260. Okay, and it provided us with an equation for this. Now, I want to go ahead and go a little step further here with this data. Okay, so hopefully we can all make a scatter plot now. Now, if I wanted to find a model for linearly related data algebraically, okay, I would use the data from the previous example, select 2 points and find the slope containing the points, calculate the y-intercept, and write the model and interpret the slope. So I have the same problem here, and what it's doing here is it's suggesting 2 data points on my graph, which is 46 and 368 and 64 and 422. And it's saying to use those 2 data points to calculate my slope and ultimately my equation. So M slope is y2 minus y1 over x2 minus x1. Formula hasn't changed in 100 years. So this is 422 minus 368 divided by 64 minus 46. Okay, at this point you can use your calculator if you want to subtract numbers and divide and so on. Okay, so I've got 422 minus 368 gives me 54, and 64 minus 46 gives me 18, which is equal to 3. Okay, my slope is 3. So far we know that y is equal to 3x plus b. In order to calculate that b value, we would take either one of these coordinates and substitute for x and y. I'm going to use the first pair of coordinates. So 368 is equal to 3 times 46 plus b. So 368 is equal to 138 plus b. And if we take away 138 from both sides, we see that b is equal to 230. So my model, okay, my linear equation, remember a linear equation applied to a practical situation is called a model. So y is equal to 3x plus 230. Okay. FYI, I want you to compare that to what we got from the calculator. The calculator gave us 2.42 plus 260. So what I'm going to do is, instead of using the calculator's suggestion for data, I'm going to put in what we calculated. And we got 3x plus 230. Remember, we picked 2 exact points. And now you can see what the calculator is doing, right? It's taking that first and last point and putting the line of best fit through the 2 points. Okay, so capture this, which is likely a little more efficient than what the calculator actually did for us, isn't it? Okay, this is the line, the actual line from our algebraic calculation passing through these 2 points that they told us to use. Now compare this to the graph that the calculator gave us. I don't know which one you want to believe in, but I would go with my algebraic calculation. Okay? All right, now the second part of this question says to use the linear equation you found in part, and notice there's a typo here, so when you do this question, make sure you anticipate that this should be part A, not part C. use the equation you found in part A to predict the calories when X is equal to 52.6. So Y is equal to 3 times 52.6 plus 230. And that is 157.8 plus 230, which is equal to 387.8 calories. So this candy bar weight 52.6, which is not listed in our data table, will have a candy bar of 52.6 grams will have 387.8 calories based on our linear model. And part C is asking us to interpret the slope, again, typo found in part A. All this slope, remember the slope that we found is equal to 3. All this slope is saying is that if the weight of the candy bar is increased by 1 gram, then the number of calories will increase by 3, since M is equal to 3. Okay, short lesson today, but that's everything that I have to tell you.